Probability is something that's used a lot in everyday life. And you've probably seen it and experienced it all the time. The probability of something happening, is a ratio. So it's the ratio of the number of ways it can happen, the thing you want to happen, over the total number of outcomes. So since this is a ratio, we can write it a lot of different ways. We can write it as a fraction. So let's say we were talking about coins, and you said, what's the probability of flipping a head? Well, there's one head on a coin out of two total possibilities. You could get heads or you could get tails. So you could write it as 1 over 2. Alternatively, you could say 1, with colon in between, and 2. Or you can write it as a percentage, and in this case it would be a 50% chance. So when you think about it with a percentage, you notice that all probabilities are going to lie between 0 and 1. And the closer it is to 1, the more likely it is to happen. Because if you had a probability of 1, that would mean 100%. If you had a probability of 0, that means 0%. There's no chance it would happen. So let's think about a deck of cards. A typical deck of cards has 52 cards in it. And some of these cards are numbers, some of them are different suits, some of them are face cards. So let's just look at a few possibilities in there. Let's say we want to know the probability of drawing an ace. Well, you know that there are 4 aces in a deck of 52 possible cards. So the probability of getting an ace, drawing an ace out of your randomly drawn amount of cards is 4 over 52, which can be simplified to 1 over 13. So you'd say you have a 1 out of 13 chance to draw an ace. You could also do this as a percentage, and I think it's about 7.69%. Alright, so let's think about another type of cards situation. Let's say you want the probability that you draw a diamond. Well, now you still have a total of 52 cards, but now the possibilities are a little bit bigger. You have more than 4 diamonds. You actually have 12 diamonds in a deck of cards. So 12 out of 52 is the ratio or the probability that you would draw a diamond. If you want to think about this as a fraction, you could simplify that a little bit to make it 3 out of 13. Usually probabilities are simplified. And again, if you want to think about it as a percentage, you just need to actually carry out that division. You would end up with about 23.08%. Now, where things get a little bit trickier is when you have more than one thing going on. So let's say I want to know the probability of drawing a king and then a queen. So this sort of steps it up a bit. Originally, you want to draw a king. There are 4 kings out of your 52 cards. You also want to draw a queen on your second draw. Well, there are 4 queens, but you no longer have a possibility of 52. There are only 51 cards left because you actually took one of the cards out, right? So when you have a probability, when you want 2 things to happen, what you do is you multiply these probabilities. So we would have a 4 out of 52 chance and a 4 out of 51 chance. We multiply these two to figure out what is the probability of drawing a king and a queen. At this point, it's probably important to point out that I was pretty specific in that I wanted a king and then a queen. If we were to just say a king and a queen, any random order, then this problem would change a little bit. But as I chose to go with a more difficult situation, a king and then a queen, we would multiply these two. We would get 16 out of 2,652, which is a 4 out of 663. That would be your probability. If you want to do this as a percentage, it's going to be 0.006, which is ridiculously low. This percentage would be quite a bit higher if I had said just a king and a queen in any random order. Now, the reason that these two were multiplied is because the result of the first one and the result of the second one are related to each other. Let's say I just cared about drawing a king or a queen. So I'm just drawing the one. In this case, we're not going to multiply them. These are two separate events. They're independent of each other. So we know that the probability of drawing a king is 4 out of 52. And then we could have a queen. That's okay. That would be 4 out of 52 as well. Now, in this case, they're not depending on each other. So what we do is we add these probabilities. So the probability of drawing a king or a queen is going to be 8 out of 52. Which is 2 out of 13. Which is about 15.38%. Now again, it's important to note, this one, they were depending on each other, so this is a dependent situation. In this one, they were independent. In the second one, they were independent. So a lot of stuff is talked about and probabilities and or probabilities. And or is where we're going to add them together, and is where we're going to multiply them together. So let's look at a couple other situations and maybe revisit that independence and dependence thing. Say I have a bag of poker chips. And I have some poker chips in my bag. I have 5 blue poker chips, and I have 7 red poker chips, and I have 6 black poker chips. So altogether, let's see, we have 18 total chips. Let's use this to think about a couple things. So if I were to ask you what is the probability that I'm going to draw a blue, it would be 5 out of 18. I have a 5 out of 18 chance of drawing a blue out of my bag full of poker chips because I'm that awesome and have a bag of poker chips. So that would be about 27.78%. So now let's think about a not situation. What is the probability of not pulling a black? Well, you can do this one in a couple different ways. Well, one thing we can think about is that the probability of something happening is out of 100%. So we could do 1 minus it happening. We could also go and find the probabilities of the other two things and figure out what that would work out to be. But 1 minus the probability that it happens is usually the easiest way to go. So let's just start out assuming that we do have a black. If we do draw a black, we're going to end up with 6 out of 18. That's the probability. And this simplifies to be about 1 out of 3. So the probability it is black is 1 out of 3, but the probability of it not being black would be 1 minus 1 out of 3, which would be 2 out of 3. So you have a 2/3 chance that it's not black when you draw it. And of course, you can go ahead and put that as a percentage if you'd like to, and it would be about 66.67%. So let's look at another independence-dependence kind of thing, just to mix it up a little bit. Let's say we want to know the probability of getting a red, then a blue. Well, we need a red and then a blue, and so this will come into play when we think about the fractions we use. The probability of getting a red on your first chance is going to be 7 out of 18. The probability of getting a blue, well, you have to assume that you got a red in the first one. So the probability of getting a blue is 5 out of now just 17 chips that you have left. You can go ahead and multiply these to find the probability of getting a red poker chip and then a blue poker chip. So that ends up being 35 out of 306, which is about 11.44%. And again, you could think about a red or a blue, and you would end up adding your probabilities again, just like we did with the cards. This one sort of puts everything together. I was inspired by a book I read recently. You have two investors that you use to buy penny stocks. Investor A gets you a win 45% of the time, while Investor B gets you a win 55% of the time. When you call the firm, there's a 3 out of 5 chance that you will get Investor A. What is the probability that you will get a winner on any given day? So this one's a little bit complicated, and it helps to draw a tree diagram for this one. First off, you want to think, well, who am I going to get when I call? Regardless of the winning percentages, you're not going to be able to think about that until you know who you get, A or B. So it says there's a 3 out of 5 chance that you will get Investor A, which means there's a 2 out of 5 chance that you'll get Investor B. So if we were going to put this in a tree diagram, I would say, okay, 3 out of 5, I get Investor A. 3 out of 5 is a 60% chance, or 0.6. And then that means that there's a 2 out of 5 chance for B, which is 0.4. Now let's just say that 60% chance becomes true. Now you have two possibilities for Investor A. You might get a win, or you might have a loser. So the probability that you're going to get a win is 45%, and the probability that you're going to get a lose with Investor A is actually 55%. So now you have Investor B, and he's sort of the opposite. If you have Investor B, the probability you're going to get a win is 55%, which means the probability that you're going to lose is 45%. You want to know the probability that you will get a winner on any given day. So let's think about winning. In this case, our winner would be this path or this path. So we have a couple of different possibilities here. So let's start out with the A. We know that Investor A has this 0.6 as the probability that you'll get him in the first place, and then 0.45 that he'll get you a winner. So the probability of that particular outcome, since both those things need to happen, is 0.6 times 0.45. So now you can just do the calculations with your little calculator. You can see that he's going to give you 0.27 or a 27% chance of getting a winner. So that's if you pick up the phone and you get Investor A. Now let's say you get Investor B instead. So that's the second path. Well, we know that that was 4% to begin with. So that outcome has 4%, or 40%, excuse me. And then he has a 55% chance of getting you a win. So you need both these two things to happen. So again, this is a multiplying. So you're going to do 0.4 times 0.55. You're going to get a 22% chance if you pick up the phone and you get Investor B. Now, if you want to know just the probability that you're going to get a winner, you don't really care which investor that you work with. You have a 27% chance if you work with Investor A. You have a 22% chance if you work with Investor B. But either of these two things could happen. So we started with dependent parts. Now we have two independent probabilities, and we can add those two independent probabilities to figure out your probability on that given day. So 0.27 plus 0.22, 27% plus 22%, is going to get us 0.49. So you have a 49% chance of getting a winner on any given day. If you think about the stock market, that's a pretty good chance that you have for making some money. I know that I didn't really do a lot of examples in this one, but probability is really kind of doing the same thing over and over again. You have to diagnose the situation before you know what to do, though. So remember that probability is the total number of it happening, whatever you want to happen, out of the total number of outcomes. And you know that when you have different situations, sometimes you have to combine probabilities or consider the other case. Like if 3 things needed to happen, you need to consider how those first 2 things change the outcome of the last thing. So a lot of the times we have and problems and we have or problems. So if you have a probability that's and, it means both things need to happen, and so they're dependent on each other. And this is where you multiply the probabilities. You typically, in an or problem, these are independent of each other. And you add them together. Now, this is a big generalization that I'm making here because probabilities have a lot of different things that go into them and a lot of different things you need to think about. But in general, this is a good rule of thumb for remembering what you do with probabilities with multiple events. Obviously, each event is a little bit specific. For lots more examples and practice, there's tons of stuff on the internet, and you can also check out anything that was linked on the Canvas page.